So the question tells us that the speed belt of a ramp, maybe in an airport, is moving at a certain speed, and this guy named Cliff is in a hurry and decides to skip the ramp. So it asks us, what is the speed at which the belt of the ramp is moving? So the information that the question gives us is the change in time in which it takes to complete the ramp if you go on it. And that's 63.8 seconds. And that it tells us his initial velocity is 0 meters per second. And his acceleration whenever he begins to run is 0.307 meters per second squared. And we want to know the final velocity, or the speed at which the ramp is moving. And so that's what we're looking for. So in order to first find the velocity, which is in units of meters per second, we first need to find the length of the ramp. So in order to find the length of the ramp, or the delta x, we would use this equation. Delta x equals velocity initial times change in time plus 1/2 acceleration times change in time squared. However, in this question, the initial velocity is 0, so this first part of the equation becomes 0. So that leaves us with delta x equals 1/2 times the acceleration times the change in time squared. So that would be 0.307 meters per second squared times 15.95 squared, because the total change in time in which it would take to get on the ramp is 63.8 seconds, and it says that he skips the ramp and takes 1/4 of the time it would take to be on the ramp. So that's 63.8 seconds divided by 4. And so that's where you get 15.95 squared, and that's times 1/2 or divided by 2. And so we get 39.05 meters is the length of the ramp. Then from there, we can just plug the length of the ramp into the velocity equation, which is velocity equals change in position over change in time. So that would give us 39.05 meters divided by 63.8 seconds, giving us 0.61 meters per second is the velocity, or the speed, at which the belt of the ramp is moving.